Hey everyone, welcome to the fourth week of General Chemistry 2, and our topic for this week will be all about concentration of solutions. Now in this lecture video, I am going to answer the practice problems found in your LMS. So let's start with the percent by mass. Here is the problem in your LMS. If 28.5 grams of calcium hydroxide is dissolved in enough water to make 185 grams of solution, what is the percent by mass of carbon hydroxide in the solution? Now take note that percent by mass can be computed by this formula. So mass of solute divided by the mass of solution. And we could get the mass of solution by just simply adding the solute plus the solvent times 100. Don't forget that. So in this problem, we have here the mass of solute. Our solute in here is obviously the calcium hydroxide. And of course, our solvent is the water, which is already in a solution in here because it already stated 185 grams of solution. So using the formula, percent by mass is represented by percent W over W, or sometimes it's also M over M. Okay, so we write the mass of the solute, which is the 28.5 grams, over the mass of solution. It's already in a solution in here. It's 185 grams. Okay, times 100. So 28.5 divided by 185 times 100, the answer therefore is 15.41%. Now take note in this example, the mass of the solution is already expressed as it is in solution, but if it happens that it is not in a solution yet, then you need to add the mass of the solute and the mass of the solvent. Next concentration unit is the percent by volume. So here is the example or the problem in your LMS. Find the percentage of a solution that is made by mixing 150 ml of sodium silicate in 880 ml of solution. Now, your formula in here is percent by volume is equal to volume of solute over the volume of solution times 100. Now, in percent by volume problems, it usually uses two liquid substances. Now, how are you going to determine if what is the solute and what is the solvent in the problem? Now, as a review, based on the topics that we had discussed previously, solute, take note, has a lesser value, or they are in lesser amount compared to the solvents. Okay, so in this problem, therefore, the volume of the solute is the 150 ml sodium silicate, and obviously the volume of the solution as expressed in here is the 880 ml. So if you are going to solve now, the percent by volume, which is percent V over V. So you just have to divide 150 ml over 880 times 100. So the answer will be 17.05%. Now take note, these percent by mass volume or mass volume problems are just so easy, but always remember to make the units the same. Okay, so especially in this percent by volume, if one is expressed in ml, then the other unit must also be in milliliters. If that is in liters, then the other unit must also be in liters. The third one is the percent by mass volume. So here is the problem. Find the percent by mass volume of a solution that is made by mixing 2 grams iodine in enough carbon tetrachloride to make 80 milliliters of solution. The formula for percent by mass volume is you divide the mass of solute in grams by the volume of the solution in milliliters times 100. Now take note, in this percent by mass, it uses a standard unit for the volume of the solution. It must always be in liters. So it must be in grams and then in milliliters. If the given values are not yet in grams or in milliliters, then you need to convert them first. In this case, we have here 2 grams of iodine. So this is our mass of the solute. And obviously, the 80 ml of the solution is the volume of our solution. So if we are now going to solve, percent W over V is equal to, the mass of solute is 2 grams divided by the 80 milliliters of the solution times 100. So 2 divided by 80 times 100, the answer will be 2.5%. The fourth one is the mole fraction. Okay, so as the name suggests, we are getting in here the fractions of the substances expressed in moles. So here is the problem. Calculate the mole fraction of sulfuric acid in 8% aqueous H2SO4 solution or hydrogen sulfate solution. Assume 100 grams of the aqueous hydrogen sulfate solution. Okay, so in here, it seems like there are missing values, okay? But if you are going to analyze, since 8% is already given in here, take note, aqueous solution, the solvent is always water. So for aqueous solution, it's always water to be the solvent, okay? So that means to say, if 8% of it is the solute or the H2SO4. So what is the percentage remaining for the water? So you just have to simply subtract 100% minus the 8% H2SO4 to get the percentage of the water. So in this case, it's 92% water. Now it says in the problem that we assume 100 grams of the solution. So that means to say that if that is 8%, then that is just equivalent to 8 grams H2SO4. And if that is 92% water, then that is 92 grams H2O to make this a 100% solution. Okay, so as you can see, we have here units that are expressed in grams. And take note, this is a mole fraction. Therefore, we need to convert this to moles. So just a review, when you are going to convert grams to moles, you need first to get the molecular masses or molecular mass of each substance. So let's start with the molecular mass of H2SO4. So you need to look at your periodic table. The mass of hydrogen, sulfur, and oxygen is found in your periodic table. So for hydrogen, that is 1 grams times 2 because it has 2 atoms of it, plus the mass of sulfur is 32 times 1 because it has only 1 sulfur, plus the mass of oxygen is 16 times 4 because it has 4 of it. So in your calculator, if you are going to input these values, the answer must be 98 grams per mole. And then the molar mass of water also, or the molecular mass of water. Hydrogen's mass is 1 gram times 2 plus the mass of oxygen, which is 16 times 1. Okay, so that would be equal to 18 grams per mole. So if you already got the molar masses of each substances, you are now ready to get the number of moles of each substances. Okay, so to convert this into number of moles, you just have to simply divide. So to solve for moles, you just have to simply divide the mass over the molar mass or the molecular mass. So for H2SO4, 8 grams is already given, that is the mass in the problem, divided by the 98 grams per mole that we had just solved. Then the answer is 0.08 moles H2SO4. Cancel grams. Now for water, it's also the same, 92 grams from the problem and then 18 grams per mole for the molecular mass. Cancel grams. The answer is 5.11 moles. So if you already converted it to moles, then you are now ready to get the mole fraction of each substance. So to get the mole fraction of H2SO4, take note mole fraction is represented by letter X. So it says in here, in the formula, you just have on this one, you just have to simply divide the number of moles of that substance over the number of moles of that substance plus the other substance's mole. Okay, so in this case, the number of moles for H2SO4 is 0.08 over its moles again, 0.08 plus the mole of the other substance, that is 5.11 for water. So if you are going to calculate it, the answer is 0.02. Take note that there is no unit for mole fraction because as you can see, mole unit is both found at the numerator and the denominator. Therefore, the unit cancels out. So there is no unit for mole fraction. And the mole fraction for water, therefore, is 5.11, the number of moles for water, divided by 5.11 again, plus 0.08 mole for H2SO4. If you are going to calculate it, the answer is 0.98. So the answer for this problem is 0.02 and 0.98. Now to check if you got the correct answer, these two must be equal to 1. So 0.02 plus 0.98, that would be equal to 1. So our solution is correct. Next concentration unit is molarity. A solution of sodium hydroxide contains 19.2 grams solute in 160 cubic centimeters of solution. What is the molarity of the solution? Now for molarity, the formula is mole per liter. Moles of the solute divided by the liter of the solution. Okay, take note from the given that we have 19.2 grams of sodium hydroxide. The sodium hydroxide in here is obviously our solute. So since molarity is mole per liter, we need to convert this to moles. Okay? And then the 160 cubic centimeters, since the unit also for molarity requires liter in the volume of the solution, then we need to convert 160 cubic centimeters to liters. And take note that 1 liter is equal to 1,000 cubic centimeters. So that would be equal to 0.16 liters. Okay? So we are now going first to convert 19.2 to moles. Okay? So again, we need to get first the molecular mass of the sodium hydroxide. So the mass of sodium is 23 times 1 because it has only one sodium, plus 16 grams for oxygen times 1 plus 1 gram for hydrogen times 1. So all in all, the molecular mass is 40 grams per mole. So we are now ready to convert this into moles. So mole sodium hydroxide, again it is mass divided by molecular mass. So the mass of NaOH is 19.2 divided by 40 grams per mole. Cancel this one. The answer will be 0.48 moles sodium hydroxide. And then we are now ready to solve for molarity. Okay? So molarity is mole of solute divided by liter of solution. So the mole of solute is 0.48 moles divided by the one we converted to liters, that is 0.16 L. So the answer here is 3 m, or you may also use the unit mole per liter. The last one will be on molality, represented by small letter m. So what mass in kilograms of silver nitrate has been dissolved in 200 grams of water if the molality of the solution is 0.3 m or mole per kilogram? Now for molality, on the other hand, it's moles of solute divided by kilogram of solvent. So it's a mole per kilogram. So if you are going to write the given, if you are going to read the problem carefully, the molality is already given. So that is 0.3 m or mole per kilogram. And then the mass of the solvent is also given, that is 200 grams, but we need to convert it to kilogram because kilogram is the standard unit. So since 1 kilogram is equal to 1,000 grams, then it would be equal to 0.2 kilograms. So the unknown now in here is the mass of solute in kilograms. So the unknown in here from this formula is the numerator. Okay? So we are now going to solve first the moles of solute from this formula. Okay? So since m is equal to mole per kilogram, this is the unknown. We represent it with letter x. Now the molality is already given, so that is 0.3 mole per kilogram equals, this is the unknown, the mole of solute, we write it that way, over 0.2 kilograms. And then cross multiply, so kilogram here will be cancelled. And then mole solute therefore is equal to 0.3 moles times 0.2. So the answer in here is 0.06 mole silver nitrate. Okay, so we need to convert this first into grams. Okay, so because the unknown in here must be expressed in mass or in kilograms, so we need to convert this step by step. So for this 0.06 moles, we need to convert this first into grams. So again, we need to calculate the molecular mass of silver nitrate. So the mass of silver from the periodic table is 108 grams times 1 plus 14 grams, this is for nitrogen, times 1, and 16 grams for oxygen times 3. So if you are going to calculate this, the total is 170 grams per mole. So if you are now going to convert this time moles to grams, then you just have to simply, okay, mole of solute. In order to convert this into grams, you just have to multiply the number of moles times the molecular mass. That is the standard formula. So we already solved for the moles a while back. That is 0.6 moles times the molecular mass, which is 170 grams per mole. We cancel moles, so the answer is 10.2 grams. Okay, now this is now the mass of the solute, but take note, the problem is asking us what mass of that silver nitrate in kilograms. So this is not yet the final answer. We need to convert this to grams. So again, 1,000 grams in 1 kilogram. Therefore, the final answer is 0.0102 kilograms. This is the final answer. Okay, so I hope you learned something from this video. If you have any questions, please feel free to ask your teachers. And the performance task is already given in your LMS. So again, thank you for watching, and I want to end this video with this quotation: spend more time with the solution than the problems. Good day, everyone.